We present PorosityAnalyzer, a tool for visual analysis and evaluation of segmentation pipelines to determine the porosity in fiber-reinforced polymers. Here you see the computation module, which provides a GUI for connecting segmentation pipeline filters within user-defined parameter spaces. The created segmentation pipelines can then be batch processed. To set up a segmentation pipeline, we drag and drop the dataset and filter icons. We have to define the parameter space sampling for each filter in the pipeline. We then add a created pipeline to the segmentation pipeline batch table. By pressing the Run Calculations button, we start the batch calculation of the defined segmentation pipelines on this machine. We then load the generated segmentation results into the analysis module. In the pre-filtering stage, the user can pre-filter the data by selecting the segmentation pipelines or datasets. The contents of the tree view and the overview comparative matrix are dynamically updated whenever the filter settings are modified. The overview comparative matrix in deviation mode color codes the median deviations of each segmentation pipeline dataset combination to the reference porosity values. The box plot mode shows more details on the distribution of the porosity values. The reference porosity value is indicated with a vertical red dashed line. The histogram mode depicts one porosity value histogram per segmentation pipeline inside a matrix cell. Selecting a matrix cell will forward the segmentation data to the analysis stage where they are presented in the scatter plot matrix and in the parameter range sliders. The parameter range sliders were implemented to assess the sensitivity of the variations in input parameters when evaluating a segmentation pipeline. They operate on the histogram plots of the output parameters, porosity and porosity deviations, and on the input parameters of the corresponding segmentation pipeline. By selecting a range in the output parameter histogram, the corresponding range of the input parameter histogram is highlighted. The selection made in the parameter range sliders is interactively synchronized with the scatterplot matrix. Multiple selections can be managed and organized using a selections view. We now perform a trade-off analysis between deviation to the reference segmentation and the runtime. We select bad parameters and add them to the selections view. We now compare the segmentation results of two parameters by using the region of interest widget and the pop-up preview. Therefore, we fix one data point in the scatterplot matrix. When hovering over another data point, the differences in pore regions are displayed color-coded in the pop-up preview. The yellow overlay indicates those voxels that are the same in both segmentations. The newly added voxels are color-coded in red. We now compare two selections of segmentations with good and bad parameters in the visual examination stage with 2D slice views and 3D volume renderings. On the left you see the segmentation results with good parameters, on the right the segmentation results with bad parameters. The aggregated segmentation masks are color-coded in pink. The reference segmentation mask is color-coded in yellow. The statistical contours show the minimum, median and maximum porosity value of a selection of segmentation masks.